Welcome to this session on adhesives. So my name is Valerie. I'm working for Dow in the silicones business, obviously, and I will be chairing this session. Our first speaker is Graham. Graham works for Eckersley O'Callaghan, and it's always a pleasure when he contacts you with crazy ideas to test. Today we'll try to see how to do more with less. The floor is yours.
Thank you, Valerie. This talk has been sort of long time coming, but before we get to sort of the rub of nub of the matter, we've been making big, tall glass facades for a long time, and glass is one component. So a big shout out to the silicones because it holds it all together, and it's a combination of all those materials coming together. And 25 years ago, when we were doing sort of very simple facades using these sort of details, there was this consideration that why can't we use sort of all the width of the fin for bonding? And the point was that we can't really guarantee that a silicone is going to bond to the to the interlayer. So we just ignore it, and before we sort of started talking about circularity or anything, that was fine. But what we started sort of 2 years ago was saying, well, okay, what actually is that? And so on the left, you've got a fairly sort of typical glass to fin design. Typically now move towards the right-hand side where you can distribute the load through the metal plate and get some bond towards the center. But generally, I'm going to take the sort of improved glass fin version as sort of the reference design, if you like, to just to explore the idea of what happens, or what is actually the effect of the adhesive between the silicone and the interlayer. And going back, it's easy to see why we've typically worked in that way. 'Cause this is just a sample in our office. It's not very nicely finished edges, and you can just see the chamfer, and the interlayer is filling that gap really rather well, and it's a nice sample. But with this panel here, we're always just looking to bond, or what we're allowing ourselves to use is bonding on the flat face. So as going back to the previous example, we've got all the applied silicone on the left-hand side and the interlayer protrusion. But there's a vast amount of orange there, which, although it's sitting there, we know it's going to be doing something. But to date, really, we've been ignoring that. So the first step really was to say, okay. I'd say with great help with Dow, who've been doing the testing for this, and Crary providing the samples. What we did is we asked Crary to process some glass plates with an interlayer on, and they were transported to Dow for this peel testing. So, as I said, we've got some very small sample set, three of each interlayer type, so Century Glass 5000, 6000, and a PVB product. And no primer, all via the standard test. And you've got this, I don't know if you've seen this before, but you've got a mesh laid into the silicone. And the point of the test is to make sure that silicone is failing cohesively. It's not debonding, and so therefore we can accurately predict what that joint would be doing in its service life. And these are the results from those tests. So out of a total of 9, 1 failed in adhesion. So you can see this nice, well, it's not a nice result, but we've got some clear debonding there. But 8 out of 9 isn't too bad. It sort of says, okay, well, maybe there's something in this. And it also led to the question of, okay, what is perhaps the possible benefit? What might be the upsides to this. And so, again, we went back to our diagram. We looked at, what the nominal width, reduced width was, and we did some really very simple calculations. And we've got this graph here, which is, this is what's happening if we're looking at the full silicone bite, and this is sort of the capacity of that joint with a reduced silicone bite. So, they've got the thin spacing from 1 to 3 at the bottom here, and wind loads. When we've got narrower winds, it can support high wind loads, very high wind loads. So that was interesting. So it's about a 38% design benefit, not particularly rigorous level of calculation, but what are we looking at? What's the scale of this improvement? But another perhaps larger aspect is not using all the silicone, it's considering material. And I certainly remember some time ago when we did a lot of these, is that the design was limited by the silicone bond. And what we had was that we're trying to get as much silicone to bond it. And rather than having 4 sheets, we're sort of putting additional sheets on just to allow the area of silicone to be significant enough to transfer that load. And that's obviously not a great use of material at all. So I think there are some considerable benefits to how we look at this. The next stage, and this is the stage that we are now in the process of, is to do these H-sample tests. And you might have heard Valerie talk about these H-sample tests yesterday. And it comes from research with BAM and looking at what the adhesion is to organic coating. So it's referencing that, sort of using that as guidance. And what we did in this case is we increased the sample number to get a better surety of results, and we reduced it to just century glass and PVB. Also, we for an adhesion, so on the basis for adhesion, there's a paint adhesion test or a coating adhesion test where you score the surface, so you can see how that peels up off the surface. So the sample is 50 by 65. We've got the silicone bites in the middle. Again, we've got a pre-processed glass sheet here with the interlayer on the surface. And from that, there was the first scale of testing. So these are unweathered, unaged, and 5 of them tested in sear, 5 of them were tested in shear of each sample type, and 5 of them in traction. And this is the rig here showing the traction. You can just sort of see the interlayer surface here, and you can see it's being extended in that test. As I said, this was done at Dow's labs. And I'm not going to show you all the results, but the statistical results shown here. And if you look at traction, both the PVB and the century glass is at 0.84 to 0.96. And there's some reference tests from glass to glass, which is 1.07. And shear, again, we're actually a little bit higher here. But, we're all pretty much in the region. So this is sort of, building up on that and saying, okay, well, there's some capacity here. So the next step was to look at, okay, well, how does that work with sort of long-term aging? And so we took the same, not the same sample set, but the other half of the sample set, and that was extended by 12.5% to give a consistent load on the silicone. And then we put some spacer blocks, compression blocks on either side to keep that extension. And at the moment, now that is going into the aging process. So this is actually in progress, but it's 984 hours at 70 degrees. and it goes down for 24 hours at minus 15 degrees. And so we're really looking forward to seeing what results come out of this, because I think that there could be some significant benefit to how we look at not only how we use the material in these joints, but can we sort of start looking again about how we join pieces of glass to frames? Do we use that to run the glass to the frame? Can we use that to join the interlayer to the frame? And so, obviously we're waiting for those tests to see what those values return at. But the second stage really is looking at what effect might we have at this edge here, because we're bonding to that surface. What is the interaction between all these parts? Do we have sort of stress concentration, or how is that distributed? So I think there's perhaps some more work to be done then. But really, when looking at those early results with a range of performance in reference to the structural silicone, we're 78 to 100%. So I think then that's really very encouraging. And I think as we move on to find out how we can get more out of what we're doing, that's very interesting. Although it's a sort of simple idea, and it's about questioning why we do those things that we do, is that I find it really exciting that we've accepted this sort of status quo as it is for very rational reasons, but we need to rethink about those held tenets of, are they right or wrong? And it looks like we can squeeze a bit more out of whatever the analogy is. I've lost it now. But we can get more out of our design. So relatively short presentation today, but hoping to get those results back, and then we'll publish those, and hopefully we can continue that conversation on again. So thanks very much for your attention.